Hello, welcome to Module 9, and this is Part 2. We're talking a little bit about that Rossby wave that's forming troughs and ridges in my air currents. And I mentioned in previous modules that when we talk about the air in the troposphere itself, so in the lowest level or lowest layer of atmosphere that is only about 30,000 feet in actual height off the Earth's surface, when I'm talking about that low level area in the troposphere, I can measure it and call it as air aloft. And one of the ways that I can measure that air aloft in the topmost parts of my troposphere is by looking at isobar lines. So these are isobars. They're telling me the pressure readings at different locations, and I can see that this is a 32, 300, this is 298, so I'm going down, and these are lines of pressure. So everything along this line at this altitude has an isometric pressure or an isobar pressure of 296 millibars, MBs on my information. And so that's one of the things to just keep in mind as I'm looking at these. These are different lines of pressure here. Now, the dotted lines are wind current conditions, so they're kind of showing me jet stream action. They're showing me how the air is moving or whether it's getting stuck in one location, kind of spinning out or like dropping off in the air current directions. And then down here where it's showing vortices, it's basically saying that it's spinning on itself in these locations. And maximum vortices means that they're spinning very fast. Minimum vortices often mean that they're spinning very slow. But another way to think of this more or less, I can also identify with them where I'm developing low pressures and where I'm developing high pressures. So even though the air is spinning, some of that air is sinking and some of that air is rising in these locations. And so let's look a little bit more on this map so I can see this air current, this jet stream cut up that they have. There's dotted lines here in the light blues, and I can see that it's whirling down and then whirling back up. And right here in this little whirl right here, I can see that I'm building a trough, right? So I'm dipping down and then I'm building a ridge in this location. And then if I look at wind speeds in that, I can see that I have a low pressure that is spinning very rapidly on itself in this location. So this air is rising up on this low pressure center, and this air is then spitting out into my jet stream, which is then traveling westerly, which means that it is moving from the west to the east. And I have my little compass over here. So this is my west, this is my east, and that means the air is coming down in this collection. Air is spitting up out of this low pressure over here, and it's joining the jet stream, and it's moving up and around in this trough location here. And then right here, I can see that I have a little air pocket that's speeding or slowly rotating, right? Minimum vortices in its speed. And this is an anticyclone or a high pressure center. So air in this location is sinking down, the air that's joining it, and it's spinning very slowly, and on the surface of the earth, it's diverging or moving away. Then my trough dips back down, and I can see that I have another little low pressure center built back up here. And then my jet stream kind of spits off in this direction, and I don't actually see it build another trough or ridge. But this is an example of breaking down those Rossby waves and just looking at high and low pressures and speeds of rotations as they join the air aloft. So the air in the topmost parts of just the troposphere. If you haven't noticed, a lot of what we're doing now is utilizing terms that we've learned in previous modules, and we're now using them to explain what's going on in these other bits. And the reason why we have to use these terms is because I would have to create very long sentences to explain each one of these things, as opposed to me just saying troposphere, and you understand what I mean by troposphere in that case. Cold front formation and upper level troughs can occur along what's called the hydrostatic equation. This is a temperature state where the air is similar along that line of cold front and warm front. So they're very similar, and so it creates this kind of like pause state between the two. This is an example of my hydrostatic state, and it's set. And this is my interface between my cold front and my warm air in that location. interactions in surface and upper level patterns. You guys can read through these things. I'm going to keep flicking because I actually want to go into this where we're going to actually watch a little example of a mid-latitude cyclone and its formation. So you can basically see here they're giving you the date of April 15th, and they're telling you a little bit about what you're going to see on the map. They're also telling you that the chart has a 500 millibar chart. So you're looking at the altitude in the troposphere alone, which is 500 millibars in the atmosphere. So we're looking at an upper level chart, and we're going to see at that 500 millibar line what's going on in that set. So this is my 500 millibar line. This is a radar image of what's going on with the storm building. And here I can actually see a surface map of what's happening. And so these lines here, once again, are isobar lines, and they're telling me lines of pressure on the surface. And I can see that I have a very low pressure because it has 992. So that is 999.2 millibars if I was to read it off on that low pressure. So it's a low pressure center. And I can see that I have a bit of an open wave forming because I have my occlusion. And up here, I can actually see that mixed. This is my polar front right up here. So this is kind of a loose storm that's let loose over here. And then this is taking it just slightly above, so air aloft. And so this would be sitting on top of this map at a different height. And they're showing me that these surface conditions are not relevant at the air aloft, but this one is, meaning that I'm building a big storm event in the upper parts of my troposphere. So I have lots of cloud formation and things occurring at that upper level troposphere. So April 16th, they're going to show you this map a day later and give you a 24-hour period of how this storm has moved. And I can see that the cold front has overtaken much of the warm front, and the storm has continued to move across in the westerly winds, right? And when I cut that out, all these little polar front that got interrupted over here that's important on the surface is not important in the upper level atmosphere, but I can see that big storm event. I can also see a little break off of mixing front down below here, and we can also see that as storm events along what's called the dry line down here in the Texas regions. This also occurs where what happened here was all that cold air up in the regions of Canada, United States border got shifted and pushed down through the lower parts of the United States. And so we're expecting, for example, a nor'easter-like condition up here, and the rest of the United States is suffering with a cold snap where it's unusually cold in those locations, like 40 degrees. April 17th, another day, storm is now broken off and going out into the ocean. And the cold front is also pushing in, and what's left behind is a high pressure. And these high pressure centers that moved in after the cold front will leave the conditions in those locations unusually cold, and they'll be stuck with that persistent cold. It'll be clear. It'll be beautiful, clear skies. No clouds, but there's also no breezes coming in to break up that cold. And so the cold will snap in or persist for a couple of days after the passing of a storm event like this. And then the 18th, we can see my polar front is back online on the surface. I can see a small low pressure starting to form right here. But we can see in the upper level parts of the atmosphere, I don't see that storm event. So while there'll be little sporadic rains in various locations and kind of normal day-to-day weather conditions, I'm no longer looking at a big storm that's traveling across the United States in these sorts of events. This brings me to two more terms that I can throw at you, which is zonal. Zonal is those little anticyclones and cyclones that are happening on the surface that's creating day-to-day weather conditions, but not something that's happening in the air aloft, so I'm not looking at big storm events. And the other one is midral or mid-regional, and those are the ones that have regions where I can see consistent storm events happening over and over again. So this is something that I'll keep developing a potential mid-latitude storm in that location.